Welcome to Mr. M presents Multiples and Least Common Multiples. Hi everybody. In this video we're going to take a look at common multiples and least common multiples of sets of numbers. So when I'm looking at multiples, what I'm considering are multiples of a single number. So if I start with my 8 here, then I'm going to say if I had one set of 8, I'd have 8. If I had two sets, I'd have 16. If I had three sets, I'd have 24. So as you can see, I'm actually skip counting by 8 because each time I'm adding 8 more. I'm adding another set of 8. So I'm just going to continue my skip counting here. Let's go to 56. And then I'll do the same for 12. So I start with 12, and I'd go to 24, then 36, then 48, and then 60, and let's stop at 72 for now. So what I want to find are some common multiples of both 8 or 12. So it's just like it sounds. Here I've got a list of the multiples of 8. Here I've got a list of the multiples of 12. I need to find what multiples are common, the same, between both lists. So let's take a look. 8 and 12, 16. Alright, I've got my first pair of common numbers. 24 is common. It's in both the 8 list and the list of the 12s. I keep looking, and I found another one. 48. That's a common multiple as well. It's common in both lists. Now I want to draw your attention to something really important here. Notice that in the question I said some common multiples. And the reason I did that is because you couldn't really find all the common multiples, because as the number grows, you'd be getting into infinite numbers that would be multiples of 8 and 12. You could go on forever. So what I'm going to ask usually for is some, or maybe 2 or 3 common multiples, or what's really often very most important for us is finding the least common multiple. And what that means is it's like the smallest common multiple on both lists. It's the most immediate common multiple. So I found a pair of numbers here, 24 and 24, and I found a pair of numbers here, 48 and 48. What's the lowest of those numbers? What's the least of them? It's 24. So my lowest common multiple for these two numbers is 24. Now you can find common multiples with more than just pairs of numbers. Here I'm going to try with a set of 3 numbers, 2, 3, and 6. Let's give that a try. So first I'm going to find my common multiples of 2, and I think I'll go to about 20 or so. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Don't forget to fast forward if the counting's kind of boring. Let's do the same for 3, 3, 6, 9, 12, 15, 18, 21, and we'll go to 24. Sure, why not? And let's do it finally for 6, 6, 12, 18, 24, and we'll go to 30. Alright, let's take a look. We're going to look for common numbers in each list. Remember that I've got to find common numbers for all 3 lists, so I've got to look at all 3 right away and make sure that they are represented in all 3. So the first number I see that's in all 3 lists is 6. And yes, I can use the first number in my list. That's in my list of multiples. 6 is a multiple of 6. It's 1, right? 1 times 6 is 6. So I get to use that one. Then the next number I see that's in all of my lists is 12. 12 is in all 3 lists. Then if I keep looking, I see 18. 18 is in all 3 of my lists. And some sort of sharp-eyed people will recognize that 24 is in my list for 6, 24 is in my list for 3, and that if I kept going, I would get to 24 in my list for 2. So there are 4 common multiples of 2, 3, and 6. 6, 12, 18, and 24. Now, as we did before, let's decide what is the least common multiple, the lowest common number that's in both lists, and that means it's simply the smallest of my multiples. I've got 6, 12, so 6, 12, 18, and 24. What's the smallest? Of course, the smallest is 6. So my lowest common multiple is 6. Okay, so it's time for you to test yourself. So I've given you a question. What is the least common multiple, LCM, of 7 and 5? So take a second, grab a sheet of paper or something like that, solve it for yourself, and then come back and I'll share the solution with you and you can see how you did. Okay, welcome back. So while you were solving that, I went ahead and did the first little bit of work just to save you from some boring counting, and I did all my multiples of 5 and all my multiples of 7 up to the 40-50 range, around there. So what I'm looking for is simply the least common multiple of 7 and 5, so simply the lowest common multiple that appears on my list. So as I scan through, I'm seeing that numbers are similar but not quite the same until I reach 35. 35 is the first number on both lists. It's the first common number on both lists, which means it's also the lowest common multiple, the least common multiple, 35. I know that because there are no numbers here or here that are lower than 35. So 35 is my least common multiple. Hopefully that's what you got as well. Alright, so when possible I like to conclude with a real-life example of when you would actually use this math. So at my school, sometimes we do fundraisers with freezies. Our student council will sell them to our intermediate classes. At my school this year, we've got 5 classes of 30. That's an average, but let's go with it. 5 classes of 30, and the freezies that we want to buy come in boxes of 40. So what do I want to do here? I want to buy the correct number of freezies. I don't want to have too few for sure because I don't want to leave anybody out, but I also don't want to have a ton of extra freezies that I'm paying for because it's not much of a fundraiser if I am paying for product that I'm not going to sell. So what I want to make sure is that I have at least one freezie for everybody in the grade. So what can I do? Well, I know that I've got classes of 30 and boxes of 40. Those numbers are not simply going to match. I can't simply just sort of, buy one per class. That's going to be more than I need by quite a bit. So what I can do is I can find the lowest common multiple that will see me get to the number that I need. So let's skip count by 30, and that will show us how many we need for all our students. In case you haven't done the mental math, I can simply do 30, 60, 90, 120, 150. So I need about 150 freezies. I want to go as close to that as I can without going under. It's not Price is Right. I can go over. I can have a few too many. I don't want to leave anybody out. So let's count my boxes of 40 and let's see what we can find. So 40, 80, 120, 160, 200. All right, now this is a little bit tricky because the lowest common multiple between these is 120. But that's deceptive because what do I actually need? I actually need 150. So I can't go with my lowest common multiple here, okay, but I can use my common multiples list to help me. What is the multiple on the freezie list that is the closest to 150 without being under? It's 160. So using my list of multiples, I was able to figure out what is the closest number I could buy that would give me the fewest extras but would still supply a freezie for everybody. So to get my 150 freezies that I need, I would buy 160, and that would be 4 boxes of freezies. And it's good that I figured that because I could have just bought 1 box of 40 per class. But what I would have ended up there is I would have ended up with 5 boxes of freezies, 200. So I would have paid for a whole 50 more than I actually would have sold. And that would have meant that I had 50 more freezies than I needed. Not enough to get everybody another one, but too many to just throw out. It would have been a real waste. So there's a real life example where using my multiples can help me solve a real problem. Hope this video was helpful for you, and look back soon for another Mr. M Presents math video.